Let's quickly recap the user-initiated to OAuth 2 flows we have covered so far, and walk through a decision tree to help you determine when to use each flow, ensuring your architectural decisions align with the right security needs. Implicit flow. The implicit flow is the simplest OAuth 2 flow and was originally designed for browser-based public clients. However, due to its inherent security risks such as token transmission in the URL and its increasing obsolescence, this flow is generally discouraged unless there is a compelling reason to use it. Authorization code flow. The authorization code flow offers a more secure alternative to the implicit flow. It's specifically designed for confidential clients that can securely store sensitive credentials like the client secret. This makes it ideal for regular web applications that involve a backend server capable of securing these credentials. However, it's not suitable for applications that don't have this capability, such as single-page applications. PKCE flow. Proof key for code exchange. The PKCE flow extends the security of the authorization code flow. It's designed to solve the security challenges, especially for public clients like single-page applications or mobile applications, but it can also be used and is recommended for confidential clients. This flow is a secure and practical choice not only for native mobile and desktop applications, but also for traditional web applications. Now let's move on to the decision tree, which wraps everything up and provides a step-by-step guide to making the right choice for user-initiated flows. We begin by evaluating whether the flow is user-initiated. If the answer is no, then the scenario is not applicable for user-initiated flows and we stop here. If yes, we proceed to the next crucial question. Now we determine if we are dealing with public clients or confidential clients. Can the client securely store client credentials? If yes, it's a confidential client and we proceed with the authorization code flow. The next step is to evaluate whether we can enhance security with PKCE. Is there a limitation to applying PKCE? See considerations. I'll cover those considerations in just a moment. If there are limitations, we stick with the authorization code flow and that is sufficient. If there are no limitations, we extend the flow with PKCE for confidential clients and we stop here. Now let's see what happens if we are dealing with a public client. First, we check whether the client meets the following conditions. Is it browser-based application? Is there a solid reason not to use PKCE? See considerations. I will cover those considerations in just a moment. Is the risk of the implicit flow acceptable? If all conditions are met and the risks are acceptable, we proceed with the implicit flow for public clients. Otherwise, if any of these conditions are not met, we move forward with the PKCE flow for public clients. Here is what to consider when deciding whether PKCE is feasible for your use case. Prototypes or internal applications with time and budget constraints. In cases where you are developing a prototype for client demonstration or working on an internal application within a trusted environment, security enhancements like PKCE might not be the highest priority. Due to time or budget constraints, developers may opt for simpler flows if the system is not exposed to significant security risks. OAuth 2 authorization server constraints. If you are using an older OAuth 2 authorization server or custom-built solution, it may not support PKCE. In these cases, even if PKCE is recommended, the lack of support may force you to fall back on other alternatives. OAuth 2 client-side constraints. PKCE requires the client to generate and store a code verifier and code challenge, which might not be feasible for legacy systems or devices with limited capabilities. Other constraints: if you are working with external vendors or third-party applications where you don't have control over the client's configuration, PKCE might not be feasible. And for any other similar constraints where you don't have the option to implement PKCE due to the technical limitations or external dependencies, it's important to weigh the associated security risks carefully and consider the available alternatives. By carefully weighing these considerations, you can determine whether to prioritize PKCE for enhanced security or stick to alternative flows.